Coming up on How Do They Do It? How do they transport a massive steel turbine halfway around the world? How do they make a fireproof suit to protect racing drivers when all goes wrong? But first, how do they decode the valuable data contained in black box flight recorders? We show you how on How Do They Do It? Coming up, we discover how they transport this massive turbine halfway around the world. And find out how they make a fireproof suit. Next on How Do They Do It? Here, in the blistering heat of the Arizona desert, this huge turbine inches its way toward the power station where it will be installed. To get here, it's had to travel halfway around the world from a small city in Italy. So, how do they transport this massive load more than 6,000 miles over land and sea? How do they do it? It's 7 a.m. in the historic Italian town of Cremona. And before most of the residents have had their morning espresso, these guys are getting ready for an incredible journey. This 628-ton turbine has just arrived from the factory in Milan. It needs to be transported halfway around the world to Phoenix, Arizona, where it will form part of a major power station. The daunting task of moving it over 6,000 miles has fallen to structure moving specialists Fagioli. Their first dilemma is that the low loader it's currently mounted on can travel only on flat roadways. For the next leg of the journey, not only do they need to cross uneven terrain, but they'll also require a transporter that's capable of turning on its axis and moving sideways. Fortunately, the boys from Fagioli have a rather cunning trick up their sleeve. It's called the Self-Propelled Modular Transporter, or SPMT. This amazing remote-controlled platform can move in any direction and climb minor obstacles. What's more, any number of SPMTs can be linked together, enabling them to carry loads weighing over 16,000 tons and up to 3,000 feet long. To drive them, the platforms have a minimum of 16 wheels each, powered by a separate power pack unit, which supplies power to hydraulic drive motors mounted on the axles. This gives the SPMT a typical operating speed of 3 miles per hour. But while it isn't fast, it's highly maneuverable. The pairs of wheels can turn through 130 degrees in each direction, allowing it to be positioned with pinpoint accuracy. And to ensure it stays perfectly level, it has a self-leveling hydraulic suspension system. As one wheel rises over an obstacle, the others compensate to keep the platform on an even keel. The challenge for the boys at Fagioli now is to remove the huge turbine from the delivery vessel and lower it onto the SPMT. No small task when you remember it weighs 628 tons. First, the turbine is slowly positioned underneath a huge overhead gantry, which will support its weight while the brace is removed. Next, 2 custom-made steel cradles are placed under the turbine and are attached to the gantry using chains. With the turbine's weight well over 600 tons, the team has had to link together 6 individual SPMTs to support it. This new 96-wheeled vehicle needs to be positioned with pinpoint accuracy. Too much weight on one side, and it could tip up and shed its precious load. So, a series of plumb lines are used to ensure it is precisely positioned. Once the team is happy, they begin to slowly lower the turbine. After a few nervous moments, the SPMT has finally taken the full weight of the turbine. With its colossal cargo on board, the remote-controlled platform slowly crawls toward the harbor. The team must now tackle the most difficult and dangerous part of the entire operation, loading the turbine onto a 500-foot-long barge. But with the turbine weighing some 628 tons and the SPMT another 120, the team knows that they are working right at the limits of what the barge can take. If they've got their calculations even fractionally wrong, there could be a disaster. Slowly, but surely, the SPMT starts rolling forward. And as the barge starts to take the weight, water is pumped out of its ballast tanks to stop it from sinking down. One by one, the wheels roll on board, but the team won't be able to relax until it has taken the full weight of its giant cargo. After 30 nerve-wracking minutes, the turbine is on board and the team can breathe a sigh of relief. For now, at least. Because they must now travel to America with the SPMT to help the turbine reach its final destination. 3 weeks later, the multi-million-dollar turbine has arrived in the blistering 105-degree heat of the Arizona desert. It's been an incredible 6,000-mile journey from the factory in northern Italy to the power station in the desert. And it's all thanks to the boys from Fagioli and their amazing structure-shifting platform. Coming up, G-force speed and a fiery crash. How do drivers walk away unharmed? Find out next on How Do They Do It? If you want to be a racing driver, you need to be supremely fit and incredibly brave. Because in order to succeed, you need to push your car to the limits. And that means sometimes you're going to push just a little too far. Fortunately, thanks to advances in manufacturing, racing cars are now tougher than ever before, and drivers regularly walk away from accidents which once might have proved fatal. But with gallons of highly explosive fuel feeding their engines, there's one risk every driver fears: fire. So, how do they protect drivers when it all goes horribly wrong? How do they do it? It's a windy Sunday morning here at Santa Pod in Northamptonshire, England, home of European drag racing. This is the fastest, most dangerous motorsport on Earth, and the people who race here are the ultimate adrenaline junkies. One of the teams here to test their car is Fire Force. Their car, Fire Force 3, has a stylish design with a fiberglass body. But instead of a standard 2-liter car engine, they've swapped it for a Pratt & Whitney jet engine.
It's virtually a hairdryer on a roller skate.
Generating 10,000 horsepower, it can reach almost 500 miles an hour in just 5 seconds. It's so fast, it requires a pair of parachutes to slow it down. The car can go from 0 to 300 miles an hour and back in under 20 seconds, causing the driver to experience 6 Gs, which has been known to cause the retina in the driver's eyes to detach.
All motor racing is dangerous, whichever way you look at it. You've got a couple of dangers: A, the amount of fuel you carry, and B, the temperatures everything runs at.
All of this means that when things go wrong, they go wrong fast. In November 2006, at the Flame and Thunder event at Santa Pod Raceway, Fire Force Mark I exploded into a fireball. Inside the car was driver Tony Baker.
I think from start to finish, to me getting out of the car, was about 30 seconds, but it seemed an awful lot longer when I was in the car.
Incredibly, he escaped with just a few scorch marks. The reason he survived was all thanks to his fireproof racing suit. Coming up, how do they make a racing suit that stands up to 1,800 degrees Fahrenheit? Stay tuned. To find out how fire-resistant racing suits are made, we've come here, to Turin, in Italy. This ancient city is home to one of the world's biggest suppliers of racing suits, Sparco. Each suit takes an average of 2 days to complete and can be tailored to the individual driver. The aim is to produce a suit that will insulate the driver's skin from a fire and still be comfortable. This means everything from the basic fabric to the stitching and logos must all be made to the highest possible standards. The process begins by breaking the design down into a series of templates using a computer. Once this is complete, the most economical layout for the pieces is calculated and they are ready to be cut out. The most common fireproof material is a fabric called Nomex, which is mixed with Kevlar fibers to increase its strength. This is laid out on a vacuum table and cut by a computer-controlled cutting machine. However, most driver injuries aren't caused by flames, but by radiant heat. The best way to prevent this kind of burn is to add greater insulation by making the suit from 3 separate layers of fabric. These extra layers keep the heat source away from the skin for longer, while air gaps between the layers provide added protection. The very latest materials are PBI fibers, which offer excellent protection but are extremely expensive. Once the layers of the suit are complete, they're ready to be stitched together with fire-resistant thread. For correct positioning of the layers, a quilting pattern is used so there are no more than a couple inches between rows of stitches. And so that drivers will look their best, here in the high-tech embroidery lab, the suits are finished off with some great-looking logos. These are created on a computer which feeds instructions directly to over 100 embroidery machines. Finally, the suits are tested to ensure they comply with international standards. They are given different safety ratings depending upon how long they will protect the wearer from second-degree burns. This can be anything from 3 seconds for the lightest underwear to 40 seconds for the main suit. They must also demonstrate that no holes are caused by the flame. All of the materials must also self-extinguish within 2 seconds if a direct flame is applied to them. The ultimate test is to set fire to the entire suit. Gasoline burns at a fierce 1,800 degrees Fahrenheit. But incredibly, after 30 seconds, this suit is barely scorched. Fortunately for Tony Baker, he was wearing a fireproof racing suit when disaster struck Fire Force in 2006.
Everything we wear is fireproof. It's designed to do its job, and it did it perfectly. I never felt any heat.
He was able to step away from this spectacular accident with nothing more than a lightly charred suit.
I've only seen a handful of major incidents, and I think Tony's one of the most spectacular I've seen, and obviously he just walked away from it.
And when he blasts down the track in Fire Force 3, he can rest assured that however crazy drag racing might be, he's wearing the ultimate protection, should anything go horribly wrong again.